Yeah.
Please, all okay. Please start.
Oh, thanks. My name is Igor Klyushnikov. I am assistant of professor of Department Computer System Network and Cybersecurity of National Aerospace University, Hawaii. And dear organizer and participant of conference, report swarm of unmanned aerial vehicles as multi-state queuing system with non-controlled and controlled degradations is presented for your attention. The agenda of presentation is follow. Introduction with motivation, state of the arts, the aim of this works, and objective of research. Main results were different models, two models of unmanned aerial vehicles, swarm-based multi-state queuing system with non-controlled and controlled degradations are presented, and also case of study. And short conclusion with discussion and next steps for our research. The utilization of unmanned aerial vehicles for service in various requests allow to create a flexible system able to for example, deploy different tasks of networks to create different monitoring system, for example, for future smart cities, and also different delivery services, for example, for medicine, goods or food deliveries, such Amazon, Project Wings, DHLs, and different projects. But the UAV is a complex technical system, therefore, like all technical system, it can fail. And the failure of UAV while servicing a request can result in the loss of a request. But there are also a situation where the failure of individual unmanned aerial vehicles of the swarms does not lead to the termination of the mission. For example, if the mission of the swarms is to search for an object in a specified area within a specified time, the occurrence of unmanned aerial vehicles during the performing this mission does not lead to its termination, but will only increase the search time. And in this case, decrease the efficiency of these missions. Whose the unmanned aerial vehicles swarm-based sources with the approach of reliability of efficiency assessment of unmanned aerial vehicles are considered in many studies. In order to increase the amount of parcels delivery to customers safely, we study unmanned aerial vehicle delivery schedule optimization, considered the reliability on UAV, presents the concept of including the reliability issues in the drone delivery scheduling. The paper importance analysis into kinds of redundant system, K out of N, and consecutive K out of N systems suggest the possible use of the Birnbaum importance-based genetic algorithms to solve the reliability optimizations problem. Considering A UAV as a multi-state system invokes an unmanned aerial vehicles as the multi-state system. Address the reliability models of UAV taking into account of the compositions the UAV into degradable and non-degradable components. The paper swarm of public unmanned aerial vehicles as Queen networks consider UAVs utilize to build flying sensors networks as a Queen system and where swarms as Queen networks. But most of the considered works propose approaches of assessment of reliability unmanned aerial vehicles as UAV-based monitoring system, taking into account the fatal failures of unmanned aerial vehicles, but do not consider different strategies of state controls with UAV-based Queen system in case when we system system with multi-states. The aim of this work is to present model described various kinds of degradations, UAV swarm-based multi-state Queen system, non-controlled and controlled, as well as to study different strategies for distributing of unmanned aerial vehicles in swarm in case fault during servicing customers. The objectives of research are following: developing the model with non-controlled degradations, developing model with controlled degradation, and describing different strategies of UAV swarm-based Queen system utilizations, and research of result of utilization different strategies of unmanned aerial vehicle swarm-based multi-state Queen system in case study. The model of UAV swarm-based multi-state Queen system with non-controlled degradation is presented with slide and with model of Queen system, which can describe by candle Lee notation, which shown in top of this slide, with model described Queen system with poisoned process, inter-arrival rates lambda with its first letter M, also the service time with model Markov models of with Queen system shown in figure 1, where 4 set in this model. First set comprise the state where all UAV are operable. The set of states 2 comprises the states where one or more UAV are non-operable, but in this case, all request services, but with lower services rate. Set of states 3 comprise the states where all UAV are not operable and the existing requests are lost. And the set of states 4 comprises the states where all unmanned aerial vehicles are involved in services where requests. This model is an example of Queen system with non-controlled degradation, in which cases degradation is naturally, and we can't affect on this process.
Igor, do you hear us? Sorry, some problem with connection.
A different degree of importance depending on where weighting coefficient. Assume what the sum of weighting coefficient is 1. In this case, when all unmanned aerial vehicles are involved in servicing, the request and can file the various strategies for servicing a request can be discovered. Strategies without reallocation unmanned aerial vehicles, first strategies, and second one, strategies with reallocation of resources. A strategy without the reallocation of resources, in which case UAV, is utilized in case of failures of UAVs that a part of the swarm servicing the request with less weighting coefficient. In this case, coefficient G lower than coefficient G1. A strategy with the reallocation of resources is utilized in case of failure of unmanned aerial vehicles, what are parts of the swarm servicing the request with a large weighting coefficient. The reallocations of UAV in this case
because
can make
know that we have not lost the connection. It's not us. Sorry.
Igor,
it's strange, but from Ukraine, I'm continue hearing of the presenter.
Okay, let's suggest Igor to more quickly go to finish because we have. Igor, please.
I understand I have a problem.
Yes, please more quickly go ahead because we worry about connection. Please.
Yes, I understand.
More quickly.
In this slide, present an example of model with different weighting coefficient customers rates, and when utilize two swarms of UAV, and in this case we can use UAV from swarms which source request with less weighting coefficient when it is necessary to solving requests with bigger weighting coefficient. But in this case, can be situation when we don't know exactly in which states make it possible make transition, because we don't know how many UAVs in second swarms fault. With uncertainty in regard to transmission between states. And to cope with this problem, the following assumption that with one services request which less waiting coefficient can allocate a UAV only when it's on all services. The case study present the easiest UAV service, UAV swarm-based queen system, which services two kind of customers. First one is customers where need to delivery medicine with branch, and second one the customers where we need to deliver food, second branch. And very simplest very simple model, and in this case the request to deliver medicine have large waiting coefficient when request to deliver food, and when all unmanned aerial vehicles used to serve all requests, and one of them file. In this case, we use unmanned aerial vehicles, which is which we can use, and in this model, we use three unmanned aerial vehicles, one to serve a request for medicine delivery, one to serve request for food, and one is reserve. And when reserve unmanned aerial vehicles is also used, in this case, we use the unmanned aerial vehicles which serve request for food delivery, and in this case, this request lost. On this slide present system of equations which make it possible to assessment stationary probability of being system if in with different states. And for initial data presented on the top of slide, we obtain follow result. If we use strategy with reallocation, when we don't use VAV from branch food delivery, total losses of request when total amount of requests for this system equal 10,000, total loss of medicine requests is equal 49, and for food delivery is equal 16. When we use strategy with reallocation resources, in this case, total loss of medicine delivery request is equal 22, and food delivery is equal 18. But in this case, the total losses in conventional units for different weighting coefficient. If we use strategies without reallocations, in this case, non-controlled degradations, total losses is equal 27 conventional units. And when we use strategy with reallocations, unmanned aerial vehicles total losses equal 21 conventional units, with less than 24 persons. And conclusions. In our works, various Markov models of unmanned aerial vehicles, swarm-based multi-state wind system are developed and explored. An example of model servicing the request for food and medicine delivery in futures of unmanned aerial vehicles, and when the using controlled and non-controlled degradation was given and analyzed. It was demonstrated what the forgiven data utilization of controlled degradation strategy with reallocation of resource provide decreasing the overall losses of request by 44 persons. It was found what the total numbers of lost requests when applying different strategies remains unchanged. And the next research steps can cover the deployment of models, unmanned aerial vehicles, swarm-based multi-state wind system, taking into account strategies of utilizing the ground components of WISC wind system. That's all.
Thank you.
Thank you for your attention.
Thank you for your presentation. Sorry, we have not a lot of time for questions, but if you would like 1-2 questions, please.
Alexander Lubimov is here. What was the method used to assess, the weighting coefficient of the particular swarm? How do you calculate the readiness of particular swarm to do the operation?
In this case, I use building method in Excel and found probability of bending states with matrix.
Can I add maybe? I think in this case we have not any problems with calculation of.
Yes.
Yes, but problem just maybe connected with complexity of model. If in any case we can go ahead step by step. First stage is development of Markov graphs, considering quiet theory, and next one matrix, and next one simulation results. And so, as I understand, the main problems here can be related to complexity of system. Yes, because if you talk about UAV fleets, which consist of 10 or more UAVs, in this case we have more complex graph, and combining different strategy. If you use different strategies of maintenance and application, problem of complexity will become more and more. Thank you.
Okay, thank you very much. I was just working a few times with not the swarms but mesh networks with radio nodes, and having a lot of redundant data exchanges between different nodes makes model super complex, especially with the radio communication, where you have black spot problems. and continuous reconfiguration of swarms or mesh networks, it really gives some challenging problems, as I see it.
Да. If we use more complex model, it is necessary to simulation with system, because in this case take place the size explosion and very difficult to make special to obtain question which describe this model.
Okay, thank you for very interesting question and very interesting comments. What about other questions? I don't see. Thank you one more, Igor Nikolaevich. Thank you all for, thank you, Alexander, for your questions.